Hi guys, welcome to my YouTube channel. In this video, we solve the WASSCE 2026 elective mathematics theory questions. Question 1. Given that P is the set of even numbers and Q is the set of X such that X lies in between -7 and 7 excluding the endpoints, and R is the set of all numbers greater than 0, are subsets of the universal set U, which is defined as X such that X belongs to the set of integers. Find A, P intersection R, B, P complement intersection Q, and C, the number of elements in P intersection R. Solution. Let's start with A. So with A, we have to find P intersection R. P is defined to be the set of all even numbers, and R is defined to be the set of all numbers greater than 0. And so P intersection R will be giving us 2, 4, 6, 8, up to infinity, right? And so P intersection R is the set of all even numbers greater than or equal to 2. So here 0 is not included in this intersection because the set of R does not contain 0. So we are not going to include 0 in the intersection. For B, we are to compute P complement intersection Q. So let's first compute P complement. So here P complement will be the set of all odd numbers, right? Since P is the set of all even numbers. And so we are going to have P complement giving us -7, -5, -3, then -1, 1, 3, 5, 7, and so on. So then let's find P complement intersection Q. So here Q is defined to be the set of all numbers that lie in between -7 and 7, right? And so here P intersection Q is going to be -5, then -3, then we have -1, 1, 3, and 5, right? So here we are going to exclude -7 because -7 is not an element of Q, right? And also 7 is not an element of Q. C, we are to compute the number of elements in Q intersection R. So we must first compute Q intersection R. Q intersection R will be giving us, so Q is the set of all numbers that lie in between -7 and 7, excluding the endpoint, right? And R is the set of all numbers that are greater than 0. So we're going to have Q intersection R to be giving us 1, 2, 3, 4, 5, and 6, right? So then the number of elements in Q intersection R is equal to 6. And so n of Q intersection R is equal to 6. Question number 2. A binary operation star is defined on a set of real numbers R by P star Q is equal to 3P plus 2P divided by 2P plus 3Q, where P and Q are real numbers. A. Evaluate the square root of 3 star the square root of 2. And B. Find the values of x for which x star 3 is equal to 1/2. Solution. Here we have P star Q defined to be 3P plus 2Q divided by 2P plus 3Q. And the first question says that evaluate the square root of 3 star the square root of 2, right? And so here P is going to be the square root of 3 and Q is going to be the square root of 2. And so wherever we see P in this expression, we're going to substitute in the square root of 3. And wherever we see Q in this expression, we're going to substitute in the square root of 2. And so we are going to have square root of 3 star the square root of 2 is equal to 3 times P, but P is now the square root of 3, then plus 2 times Q, and Q is now the square root of 2, then divided by 2p, and p is giving us the square root of 3, plus 3q, and q is giving us the square root of 2. And so here we are going to rationalize this guy. So we're going to multiply through by the conjugate of the denominator. So we're going to have 2 multiplying the square root of 3 minus 3, the square root of 2, divided by 2 times the square root of 3 minus 3, the square root of 2, right? Let's simplify this guy. And so this guy is going to multiply this, and also this is going to multiply that, right? So we are going to have 3 square root of 3 plus 2 square root of 2 multiplying 2 square root of 3 minus 3, the square root of 2, divided by 2 square root of 3 plus 3, the square root of 2, then 2 times the square root of 3 minus 3, the square root of 2. Simplifying this gives minus 1 plus 5 on 6, the square root of 6. B, we are to find the values of x such that x star 3 is equal to 1/2. So now let's compute x star 3. And so here, p is now equal to x and q is now equal to 3. So substituting this into our expression, we are going to have 3 times p, but p is now x, plus 2q, so that will be 2 times 3, divided by 2 times p, so that will be 2x, plus 3 times 3. Then this guy is equal to 1/2. Now let's simplify this expression by doing cross multiplication. So we're going to have 2 times 3x plus 6 is equal to 1 times 2x plus 9. So we're going to have 6x plus 12 is equal to 2x plus 9. Let's group like terms and solve for x. Thus we have 6x minus 2x is equal to 9 minus 12. Hence we have 4x is equal to minus 3. Thus x is equal to minus 3 on 4. Question 3. Solve 2 times the square root of 2x minus 5 minus square root of 4x minus 3 is equal to 1. Solution. Here we have the equation giving us 2 times the square root of 2x minus 5 minus the square root of 4x minus 3 is equal to 1. First step is to move this guy to the right hand side. So doing so, we are going to have 2 times the square root of 2x minus 5 is equal to 1 plus the square root of 4x minus 3. We want to get rid of the square roots, so we are going to square both sides. So squaring both sides, we are going to have 2 times the square root of 2x minus 5 all squared is equal to 1 plus 4x minus 3 all squared. For the left hand side, we are going to have 4 times 2x minus 5x is equal to, then we now expand the right hand side. So we have 1 plus the square root of 4x minus 3 multiplying 1 plus the square root of 4x minus 3. Simplifying this, we are going to have 8x minus 20 is equal to, so we do binomial expansion. So this times this times that. Likewise, this times this times that, right? So we are going to have 1 plus 2 times the square root of 4x minus 3, then plus 4x minus 3. Thus, we are going to have 8x minus 20 is equal to, so here we have 1 minus 3, so that will be minus 2, then plus 4x plus 2 square root of 4x minus 3. So we can move these guys to the left hand side. So doing so, we are going to have 4x minus 18 is equal to 2 times the square root of 4x minus 3. And so now we can divide through by 2. So dividing through by 2 gives 2x minus 9 is equal to the square root of 4x minus 3. We want to get rid of the square roots, so we square both sides again. So squaring both sides, we are going to have 2x minus 9 all squared is equal to square root of 4x minus 3 all squared. So for the left hand side, we are going to have 4x squared minus 36x plus 81 then is equal to, so the right hand side, this guy is going to cancel out this, so you're going to have 4x minus 3. So we move this guy into the left hand side, so we are going to have 4x squared minus 40x plus 84 is equal to 0. So we can divide through by 4, so we are going to have x squared minus 10x plus 21 is equal to 0. We now solve this quadratic equation. So we find the factors. So we are going to have x minus 3 multiplying x minus 7 is equal to 0. Thus, x is equal to 3 or x is equal to 7. Question number 4. The function g is defined on the set of R of real numbers by 5x plus 7 divided by 3x plus 2, where x is not equal to minus 2 and 3. Find the value of x if g inverse of x is equal to g of minus 2. Solution. Here we have g of x defined as 5x plus 7 divided by 3x plus 2. So our focus is to find the value of x such that g inverse of x is equal to g of minus 2. So let's first compute g of minus 2. And so here x is now equal to minus 2. So we are going to have 5 times minus 2 plus 7 divided by 3 times minus 2 plus 2. So we are going to have minus 10 plus 7 divided by minus 6 plus 2. Thus we have minus 3 divided by minus 4. Hence g of minus 2 is 3 on 4. And so the new question becomes, find the value of x such that g inverse of x is equal to 3 on 4. In our new step, we are going to compose g on both sides of equation star. So we are going to have g of g inverse of x is equal to g of 3 on 4, right? G composed with g inverse is going to give you the argument, right? So here the argument is x. So this guy is going to be x is equal to g of 3 on 4. So let's compute g of 3 on 4. Thus x is now equal to g of 3 on 4, but g of x is defined to be this guy, right? And so g of 3 on 4 will be giving us 5 times 3 on 4 plus 7 divided by 3 on 4 plus 2. Simplifying this, we have x is equal to 43 on 17. Thank you for watching. See you guys in the next video. Bye.